on Chapter 6, Section 2, Graphing and Performing Operations with Complex Numbers. The complex plane provides a visual that allows us to treat complex numbers like vectors. Remember your Cartesian coordinate plane, rectangular coordinate system. The real number part is going to be your horizontal axis, which was the x-axis. Your vertical axis is going to be the imaginary axis. If you have the complex number 2, -3, think of that as the point 2, -3. You would start at the origin, you would go 2 and then down, 2, -3. The absolute value, called the modulus, is also the magnitude of the vectors. The absolute value of your complex number is the square root of the a plus the square root of the b added together and squared. Notice it doesn't have the I, it's just the coefficient. So starting to graph, -2 plus 4i and find its absolute value. -2 means we're going to start at the origin, go back 2 and up 4. -2, 4 is the point on our complex plane. -2 squared is 4. 4 squared is 16. 16 plus 4 is 20. I'm not going to allow you to leave the answer as the square root of 20. 20 has a perfect square in it, 4 times 5. The square root of 4 is 2, radical 5. Simplify your answers. Okay? So far, so good? All right. Starting at the top of the next page. Your imaginary axis and your real axis. When we are looking at trigonometric form for complex numbers, the multiplication and division of complex numbers in standard form for a complex number are somewhat complicated, and finding the powers and roots in trigonometric form. But we can think of a complex number as the process of finding the vertical and the horizontal components of a vector. When you had your horizontal vector, you would multiply it by r times the cosine of theta. And if you were doing the vertical, it would be your r times your sine of theta. So we're going to do the a and b value, which is the a and b of the complex number. It's going to be the same idea as finding the horizontal and vertical components of your vectors. R times cosine theta and r times sine of theta. R is cosine theta plus your imaginary sine theta. Your R is the square root of a squared plus b squared. The angle theta is going to be in standard position, whose terminal side contains the point of the AB. And you will see an abbreviation of this, R equals CIS theta. Cosine plus the imaginary of the sine of theta. Yeah, I don't like that, but it is what it is. If z is a complex number, then the trigonometric form of z is going to be r times your cosine theta plus I sine theta. Can't speak today. Where theta is the angle in standard position whose terminal side contains the point. Now, z is just an arbitrary variable that I picked. It doesn't mean anything special. We are going to find the value so that it's the smallest non-negative value of theta. So we don't have to worry about plus 2 pi theta. Remember all of that mess? We're just going to take the first smallest positive angle. On our assignment in the book, we are looking for the trigonometric form of 5 minus 10i. What I would do if I were you is I would kind of locate that in the plane. Like, where is 5, negative 10? It's in the fourth quadrant. Then I would write down, what is A and B? A is 5, B is negative 10. And then I would go ahead and find the R value. So 25 plus 100, 25 times 3. It's not right. 125 divided by 25 is 5, yeah. So you have the 125 is broken down into 25 times 5. The square root of the 25 is 5, leaving the radical 5 out from underneath the radical.
What, 25 and 1? No, don't answer that question.
5 times 5 is 25. Negative 10 times negative 10 is 100, giving me 125. 25 times 3 is what I had written, but it's 25 times 5. So the square root of the 25 is 5 with the radical 5. Then I'm going to use the idea up here, A equals R cosine theta. And that, let me change that to 5. Cosine of theta, A is 5, that's the first one, equals 5, square root of 5 cosine theta. When I divide by, and actually we don't even have to rationalize this because we're going to do the arc cosine of that answer anyway. 5 divided by 5 square root 5 equals cosine theta. And now do arc cosine to solve for your theta.
Ms. Philpott,
Sir?
where would you put the 5 for the R? Because I thought the R was 5 square root of 5. Or is that the Z?
Okay, so what I am doing is I am finding the A value using R cosine theta. R is the 5 square root 5 times the cosine of theta equals the A value, which is the first one.
Oh, okay.
Then I'm going to solve this problem to get my first one.
Gotcha.
And when I do the arc cosine, then theta is roughly 63.43 degrees
Oh, so you're finding the angle. Gotcha.
to find the angle theta.
That wasn't working in my calculator. So I had an error. The arc cosine of 5 over.
What I did was I did not put the 5 in. I just did the 1, simplified it, and did the square root 5.
That worked.
I don't know. I don't know. Okay, so now we need, once we have our smallest angle theta is the 63.43, then we can get the y value.
Can we do that with sign instead?
Yeah, do it with sign. Yeah. And since we are in this quadrant, we need to make sure that the 63.43 is in the first quadrant. So how do I get the angle in?
Subtract it from 360.
Yeah, I would take that answer and subtract from 360 first. So my angle that I'm actually going to use is 296. And I was looking to see how they wanted it written. So we're going to use our 5 square root 5. And then I'm going to do the cosine of 296.57 plus I times the sine of that angle, 296.57. So trigonometric form, you're putting it back in terms of trig functions.
So, we just find the angle and then subtract it from.
That's
the
why,
shading.
yeah, depending on which quadrant you're in. If you're in the first quadrant, you're done. If you're in the second quadrant, you would have to go from there. Now, because sign is negative in this quadrant, you might want to look at your odd even to make sure that depending on which quadrant you're in, if you're positive or negative.
So for this, we'd do minus I sine of,
Well, because of the odd even function, it's the same, so it's just going to be plus. Okay. If you're going in reverse, write the number 6 cosine 30 plus I sine 30 in the form of a plus bi. We would just need the a and b. The cosine of 30 is radical 3 over 2 times the 6 plus I sine of 30 is a half. Radical 3 plus 3i would put it in complex form.
oh, and that's just it?
Yeah.
Oh.
The ones that have your 30, 60, 90, 45, 45, 90 are probably going to be easier. Any problems, questions on those? I feel like I'm going through these really fast.
Why did you put the 6 on top of the number? How did
Multiply them both by 6. So kind of distribute the 6. All right, multiplying and dividing quotients of complex numbers. In standard form, multiplication and division of the complex numbers are rather complicated, while you think addition and subtraction are very simple. When you're in trigonometric form, adding and subtracting are complicated, and we're going to simplify using this idea. If your zi is your radius cosine theta plus your I sine theta, and your second one is cosine theta minus your sine. Notice these subscripts, meaning that there are two different ones, right? Then to multiply those two together, you're going to multiply your r and your second r, and then you're going to add the angles together. Okay, so you're going to take your radii that's in front, multiply those together, and then add your cosine of your first and second theta, add your thetas together and do cosine of just the one answer and sine of that same angle. You're multiplying your radii and you're adding your angles. When you're doing division, you're going to divide the radii and you're going to subtract your angles from each other. All right, so let's see if we can do this multiplication. The square root of 43 times the square, on problem number 43, the square root of 3 and the square root of 2, multiply those together and you get square root of 6. And then you're going to add your angles together. 10 plus 20.
30.
Sine of 10 plus 20. Now, what is your cosine of 30? Square root 3 over 2. What is your sine of 30?
1/2.
And are you okay if I go ahead and distribute that radical 6, or do you want me to wait till the end?
Wait till the end.
Wait till the end? All right, so the square root is 6, and then I have radical 3 over 2 plus I over 2.
What is that in front of the radical 6?
That is my square root of 6. I was going to write just 6, and then he said kind of wait, and so I kind of changed what I was writing in midstream.
Sorry.
And so, it's pen. That's why you don't write in pen, right?
Right.
All right, can you simplify it from here? Can you simplify it from there? Do I need to simplify it from there?
Just this one.
Yeah.
Just this
this
one?
Yeah.
Well, if the answer says to round to the decimals, you would just type those into your calculator and write down your decimal approximations. If they say leave them in exact answer form, you've got the square root of 6 times 3, which is square root of 18. The square root of 18 is 9 times 2, plus I squared of 6 over 2. The square root of 9 is 3, radical 2 over 2, plus I squared of 6 over 2. So those would be exact answers. If they want decimal approximations, you can just type them into the calculator and round to your appropriate decimal places.
And that's just the answer?
Uh-huh.
So,
That's the answer.
okay, cool.
Okay, so now dividing. I have 4 and 2. So 4 divided by 2 is?
2.
And then do the cosine of and subtract. 1/3 minus 1/6 is pi over 6 plus I times the sine of pi over 6. What's your cosine of pi over 6? Radical 3 over 2.
Yeah,
What's your sine of pi over 6?
1/2.
Square root 3 plus I.